Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to the second video of this chapter, Nephelometry and Turbidimetry. In previous video, we have discussed about the introductory part as well as the difference between the Nephelometry and Turbidimetry. We have started with the theoretical principle involved in the Nephelometry as well as the Turbidimetry. In this video, we are going to see the remaining part of the principle, instrumentation and different factors that are affecting the Nephelometry and Turbidimetry. If you have not watched my previous video, you can watch my previous video, and if you like the content of this video, then you can subscribe to my YouTube channel. Now, I am going to repeat some part already that we have discussed in previous video, because the principle that will be involved in Nephelometry and Turbidimetry will be linked. So let's begin with our today's session. Before that, we will see what are the learning outcomes of this session. After this session, students will be able to explain the theory, instrumentation as well as the factors affecting the Nephelometry as well as the Turbidimetry. Now, in previous video, we have already discussed this particular part. In Nephelometric measurement, the suspended particles should be small with respect to the wavelength that is used, because this is required so that scattering rather than the reflection predominates. Already we have seen that in Nephelometry, it is based upon the measurement of scattered light. That's why the scattering will occur when the number of particles that are used or the particle size that is used is less. At the same time, smaller particles undergo scattering to give rise to a symmetrical pattern of secondary rays in a space at maximum intensity 90 to the primary incident beam. And due to this reason, most of the instruments used in Nephelometry involve the measurement at the 90 degrees Celsius. Still, if the particles are larger, a small fraction of light gets deviated at right angle to the primary beam, whereas the larger fraction gets deviated at angle other than 90 degrees Celsius. So this will occur when the particles are larger. In that case, the Nephelometric measurements are made at angle which is less than 90 degrees Celsius and from the primary beam. Say for example, in the region 5 to 20 degree or even at 45 angle also. So if the particles are having larger size, then the light that is falling on the particles, it will be deviated at the angles other than the 90 degrees Celsius. And in such a case, the measurement is carried out mainly in the region between 5 to 20 degrees Celsius or even at the 45 degree. In Nephelometry, suspended particles should neither too large or not too small. Otherwise, scattering efficiency will fall. So we have to maintain the optimum particle size to use effectively Nephelometer. For measurement to be made in the ultraviolet or the visible region, the optimum particle size should be in the range of about 0.1 to the 1 gram concentration. So in this way, we can use effectively Nephelometry instrument. So this is about the theory that is involved in the Nephelometry. Now we will see the theory that is involved in the Turbidimetry. In Turbidimetric measurements, particles which are having larger as compared to the wavelength of the light do not pose much problem, because measurement depends upon the total radiations removed from the primary beam of the mechanism by which it is removed or the angle through which it undergoes the deviation. But larger particles, with the larger particles, another problem arises, that is the relationship between the absorbance and concentration does not remain linear. So in turbidimetric measurements, due to the particle size, it will not have too much problem, because measurement depends upon the total radiations removed from the primary beam or the angle through which it undergoes the deviation. That's why particles which are having a larger size, they does not create any problem. So this is about the reflection versus the scattering. Now, after the theory of this nephelometry as well as the turbidimetry, next point that we are going to discuss is the instrumentation. Now, there are sometimes two different instruments can be used for the nephelometer as well as the turbidimeter, or a combined instrument can also be used, because as I said in introductory part also, both the techniques will differ in the measurement of radiations that are coming out from the sample solution. You can see here, this is the light source which is used. Commonly light source that are used involves the tungsten lamp, which are commonly also used in the UV visible spectroscopy also. So these particular lamps are generally used because the light that is emitted by these particular lamps is falling under the visible region. Now, the light that is emitted by this light source will fall on the either filters or the monochromators. Modern instruments use the monochromators because monochromators are having advantages over the filter. Primary role of this filter or monochromator is to pass the wavelength, selective wavelength of light, and remainder wavelength of that particular light is not allowed to pass through this particular filters or the monochromators. Only selective wavelength light will be passed through these particular filters. After passing the light, that is the selective light from the filter, this light will fall on the sample cell, which is consisting of heterogeneous solution. Say for example, the suspension. When this particular light will fall on the surface of these particular particles, depending upon the particle size of these particular sample solute molecules, the either light, some amount will be reflected, or some amount will be scattered, or some amount will be transmitted. Through this sample cell solution, some amount of light will pass or transmitted, and it will go to the detector. The amount of light that is passing through the sample cell, it will be detected by the detector, and which will be amplified, or the radiations that are coming from the detector, it will go toward the readout system, and that particular readout system will carry out the amplification of the result, and it will be recorded. Now, when the light is passing through the sample cell and it is measured at the 180 degrees Celsius, as shown in this particular figure, this particular technique is known as the turbidimeter. And as I said, there is a basic difference between the turbidimeter and nephelometer is that we are going to measure the light at a different angle. And if the detectors are placed at the 90 degrees Celsius, then that particular technique is known as the nephelometry, where the light that is falling on the surface of the particles that are present in the sample cell, it will be scattered at about the 90 degrees Celsius, and that's why the detectors are placed at the 90 degrees Celsius. So this particular instrument or the detectors are placed at 90 degrees Celsius, then that technique is known as the nephelometry. And if they are linear, detector is placed linear to the incident beam, then that particular instrument is known as the turbidometer. So this is about the instrumentation that is used for the nephelometer as well as the turbidometer. Combined instrument that is used for the nephelometry and the turbidimetry is known as the nepheloturbidometry. Modern instruments uses the both nephelometry as well as the turbidometry technique. So this is about the instrument that is used for the nephelometry as well as the turbidometry. Now next point is the factors that are affecting on the scattering of light. There are 5 different factors are there which affect on the scattering of the light. First one is concentration of particles. Second one is particle size, which is the major factor that is affecting the scattering, as we have discussed in scattering and reflection also. Then wavelength, then distance of observation, and the molecular weight of the particles. Now, first effect is concentration. Now, concentration of particles will be having a different effect on the turbidimetry as well as the nephelometry. So here first we will discuss the concentration of particle in the turbidimetry. At a low concentration of particles for scattering, in case of light, Beers and Lambert's law is applicable. Here you can consider it as a S is equal to log I0 upon IT to the base 10, which can be simplified as S is equal to KTC, that is equal to minus log T. So this is the simple equation which follows the Beers-Lambert's law. Here turbidence is directly proportional to the concentration. S is nothing but the turbidence, and this turbidence is directly proportional to the concentration. That is, S is directly proportional to the C, where S is turbidence. I0 is nothing but the intensity of incident light. IT is nothing but the intensity of transmitted light. T is turbidence. C is the concentration of solution. K is the constant which is depend upon the linearity of the light. While in case of nephelometry, the equation that describes the relation between the intensity of scattered radiation as well as the intensity of incident radiation and the concentration of particles is 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 equal to Ks into I0, that is the IO into C, where the IO is nothing but the intensity of incident light. Is is the intensity of scattered light. Instead of transmitted light, here we are going to use the scattered light, and Ks is nothing but the constant which is dependent upon the suspended particles. So this equation plays an important role in case of the nephelometry. C is the concentration of solution. The next point is particle size. The fraction of light that is scattered at angle, it depends upon the size and shape of the particles. The amount of scattering is proportional to the square of effective radius of the particle. To control the particle size and shape, sample solution and standards must be prepared under the identical condition. Now we have to take following care to carry out the effective nephelometric as well as the turbidimetric analysis. Concentration of two ions forming precipitate, ratio of concentration of the solutions, order of mixing of the two precipitates, as well as the temperature at which suspension is prepared. So this is about the particle size. Then wavelength. The intensity of scattered radiation is dependent upon the wavelength of the incident light. Shorter the wavelength, shorter wavelengths are scattered to the greater extent than as compared to the longer one. Wavelength of light is chosen in such a way that analyte solution does not absorb strongly. Turbidimetric as well as nephelometric measurements are carried out using white light. Then molecular weight. There exists a direct relationship between the molecular weight and the scattering. If the molecular weight is high, then scattering is low. Then distance of observation. Light scattering decreases by distance, that is the r square, from the light scattering particles to the detector. So there should be optimum distance should be maintained between the sample cell as well as the detector. So these are the various factors which affect the scattering of the light. So here, so S is inversely proportional to the r square. So thank you. Here in detail we have discussed about the instrumentation as well as the factors affecting the scattering.